Okay, so for 4.5, we have this logic gate. It's an OR gate. The way an OR works is that the output of the OR gate is high if any of the inputs are high. So for high, we have 5 volts, and for low, we have 0 volts. And we want to choose a resistor value R so that the input current through any of the sources doesn't exceed 0.2 milliamps, right? So let's start by turning on one of the input signals. This one, VA. We make VA high, 5 volts. We make the input signal 5 volts. And let's assume the diode to be on, so it's a short circuit. And it would be conducting it. All right, so if this were a short circuit, this entire node voltage here would be equal to 5 volts, right? And I didn't say it out loud, but pretend these are off, right? If this is shorted, this entire node now is 5 volts, and these are 0 volts, then these diodes won't conduct in that direction, so they'll be off, and it all works out. And I assume that diode to be on. You could see why, but if you don't see why, assume the diode to be off, right? If the diode were off, we'd assume it to be an open circuit. And if this were an open circuit, and these were also off, I mean, this entire node, right, would be grounded and it would be 0. So we'd have 0 here. And if we turned this voltage source on, then we'd have 5 here. And so we would conduct, and we would in fact short, and that would change this entire node voltage to 5. So there's the explanation. So let me clean this up a bit. Some of you might not have needed that explanation, but some of you might have, so I'm happy I did that. So yeah, where are we going from? We're going from here. We have one of the sources turned on. So that shorts this, so this entire node voltage is 5 volts. And so we'll have this current going through the source, 5 volts to ground over R. And we don't want that to exceed 0.2 milliamps. So we solve for R, and we get R is equal to 25 kilo ohms, right? So, I mean, that sounds like the answer we want, right? But you're thinking, well, maybe, sorry. So that's the answer we want. But maybe you're thinking, what if we turn on another voltage source, right? So if we turned on another voltage source, and we're at 5 volts here, or whatever, now we're at 5 volts here, and this is now a short circuit and it's conducting. Well, still this whole entire node voltage is going to be 5 volts. And if the resistance is 25 kilo ohms, we're still going to get 0.2 milliamp current going down here, right? And now that 0.2 milliamp current would split here. We would have 0.2 there and, sorry, 0.1, 0.1, right? Like we'd split the current between those. If all 3 of these were on, and we'd split the current here, right? We'd have 0.2, Jesus, 0.2, and this would be like 2/3, and that would be 2/3, and that would be 2/3, and that. So you get it? There it is.